Hello everyone, today we're going to be doing some ATP physics questions, and I'm just putting a disclaimer out there. This video is going to be like 80% reading because physics ATPs are like just a whole bunch of Also, huge announcement guys, I'm going to be launching my first figurine U2s, so do check it out, and let's just get right into the video. Alright, so let's start off with question number 1. I've selected like different topics throughout this paper. So you'll see lenses, you'll see electricity, you'll see a bunch of things. So let's just start. A student investigates the reflection of light by a plane mirror. So over here, the student draws the line LN. So we can see LN over here clearly at the top. Then the student labels the midpoint of LN with the letter M and draws a line PR parallel to LN 10 centimeters below it. So again, basically for these type of questions, you have to like visualize everything beforehand, because if you don't visualize what's happening, what they're giving you, then the question will be very confusing. Now on figure 1.1, draw a normal to ln and at the point M and extend this until it crosses line PR and label this with the letter Q. Now what is a normal? So normal is going to be an imaginary line that we draw to help us, to aid us with like ray diagrams. It's essentially going to be a line that is perpendicular to a certain boundary. So if we have a boundary at M and we are asked to draw a normal at M, so perpendicular means 90 degrees. So this would be 90, like those 90-degree boxes, and then we would see that if we were to draw it, it would look something like this. Now we have to extend this down till it reaches PR. So let's just do that real quick. So once we do that, it should look something like this. Okay, moving on figure 1.1, draw a line 14 cm long from point M at an angle of theta is 10 as shown in figure 1.2. Label the other end of the line O. So here is the main representation. Now this isn't really that hard. All you need is a protractor. So essentially what we would do is pretty simple. We would use our protractor over here, place it at the normal. So like you see this midline, like where 90 is, it crosses the normal. It should be at this point. And let's say, for example, I'm gonna replace this with, like, let's say this is the line, this is the normal. And you can see that the 10-degree deviation from 90 to 80, this is gonna be like 10 degrees. So you can like draw a line just like this. And how do you draw this line? You see this 80 mark, you just put like a dot over here and then you remove the protractor and then you can draw this line with ease basically. So let's just say that this is what I got for 10 degrees. Let's just move on. The student then replaces a reflecting surface of a mirror along the line LN with its reflecting surface facing the bottom of the page and with the center of the mirror at M. Positions a light source and slit so that a ray passes along the line OM towards M and marks two small crosses X1, X2 as suitable distance apart on the ray reflected from the mirror. A lot of things happening. This will be confusing, but let me just simplify this to you. Now let's say that we complete this drawing and you can see the 14 cm mark. Don't confuse this. They're basically just telling you how there's going to be a ray that passes along line OM. It's going to go up just like this, okay? And it's going to bounce on this LN, the reflecting surface, and we're probably going to see X1, X2 as the reflected ray. Right, so this kind of makes sense. Try to follow along with the question. Don't start like panicking and like getting worried just because there's a lot of terminology being used. On figure 1, draw a line joining M to X1 and X2. Very simple. We're just going to draw a line that goes somewhere along this route, X1 and X2, something like this. Continue the line until it crosses the line PR and label the point where it crosses PR with T. So we can see that it continues until it crosses PR, and we're going to say that this point is point T. Measure the length of A. So we're given a distance that we're going to denote it as A, and it's line QT to the nearest millimeter, and the length of B of the line MT in centimeters. Record your measurements below in table 1.1. So what distances are we exactly talking about? We're talking about the line QT, which is going to be this. Okay, so this is going to be A, and we're talking about the line MT, which is going to be basically this thing. So let's just say that this is distance B. Now, hopefully you guys actually know how to use a scale, a ruler. Please don't mess this question up, please. This is so easy. And let's just say for our sake that the answer that we get is 1.7, 10.3. Now again, in the marking scheme, you're going to be given a range of plus minus 0.1. Calculate the ratios. R is equal to A over B. Record your answers in table 1.1. Okay, great. So you just mentioned the distance is free marker, I guess. 1.7, 10.3. And if you were to divide these two values, so you got our answer as 0.165, but again, two significant figures, so 0.17. Okay, next up, the student repeats the procedure in BC for values of 20 and 30, and the student's results are shown. And he states that R is directly proportional to Q. What is directly proportional? Directly proportional basically means that if one thing is increasing, the other thing also increases. Similarly, if one thing decreases, the other would also decrease. And inversely proportional would be the opposite. It would be if R was to increase, theta would decrease. Do we agree? Let's check this out. So we can see that as the value of R increases, the value of theta also increases. So we're going to mention how we agree with the student. And for this type of question, you just need to quote two data points and just show that yes, there is indeed a directly proportional relationship. So you can just say something like, when theta increases from 10 degrees from 10 degrees to 30 degrees, the value of R also increases from 0.7 to 0.0. Okay, moving on. So that's what the student could do so that they have more confidence in their answer to part E. Simply put, we only have three readings. What if we extend the values of theta? What if we add 40 degrees, 50 degrees? That would help us more because then it gives us a more precise answer. So we can mention how we can extend the investigation so that we get more theta values. Investigation for more theta values. Moving on, suggest one source of inaccuracy in this experiment, even if it is carried out very carefully. The staple answer is always going to be that, first of all, this wasn't done in a dark room. And the significance of this is because other light rays might interfere with the experiment. So another error that we could see is that the student places the reflecting surface of the mirror facing the bottom of the page, which essentially means is that when the light ray hits Ln, it is not exactly hitting the reflective surface. So that is yet another error. So we could say that specifically for this experiment, so we would mention how the reflective surface faces the back. Yet another thing you could mention is very common in ray diagram experiments is the thickness of the light ray is difficult to measure, and also the center of the light ray is difficult to locate. So that is going to be yet another source of inaccuracy that we could include. Now let's go over this question carefully. A student investigates the resistance of wires in parallel. Draw a voltmeter connected so that it measures the potential difference across terminals X and Y. Very simple. Between X and Y, we're just going to have a straight line just like this, and in the middle we'll just add like a big circle with the letter V in it. So you guys might be like, but this is series circuit, so I don't think this is parallel. Well, you guys are wrong, because number one, you can see that this is a branching point and not a continuation. So this is indeed a parallel circuit. Then a student connects crocodile clip A to length 80 cm of resistance wire A. Draw an arrow to indicate precisely between which 2 points she should measure length 80 centimeters for wire A. Now for wire A, we obviously need to start from the beginning, so we would say this point over here, and we would say that this extends to, for example, 80 cm for wire A. Let's say this is 100, so this might be like 80 cm right over here, like an approximate estimation. So this is going to be the answer. Let's speedrun this. Read and record in the first line and the values of V and I shown. Okay. Both, so let's measure this. Pretty simple. We can see that V is right now at 2.9, and you can see that A is at around 0.3, 0.3, 0.3, 0.4, 0.36. So 0.36 and 2.9. The student connects crocodile clip B of length 80 of resistance wire B so that A and B are connected in parallel. The student connects crocodile clip C, and all of them are just connected in parallel essentially. So in each circuit, she measures V across X and Y and measures I in the circuit. Her readings are shown. To calculate the resistance, pretty simple. We even learned this in theory. You do R is equal to V divided by I. In this question, just make sure that your significant figures are consistent with the data. You can see that this is two significant, this is also two significant figures. Record a resistance RA. This is the value of R from circuit A. The student suggests that the values of R, A, B, C should be equal. State whether your results support this investigation. Use values from your results to justify your answer. Limits of experimental accuracy. Now what this basically means is, whenever we have a bunch of values like this, what are the chances that these values are actually matching instead of being like, due to random chance? So for that, we calculate the percentage difference, and if the value is going to be less than 10%, then the experiment is considered to be within the limits of accuracy. So let's just do a calculation real quick. We're going to do the highest value over here, which was 8.1, and we're going to subtract this from the lowest value. And when we do this, we have to divide this by the largest value. If we do this correctly, we should get to our answer 8.6%. So we're going to say that this is, yes, it is indeed, our results do support the investigation. And we're going to say that we're going to show our calculation and be like, this is within the limits of accuracy. So hopefully this is clear. Limits of accuracy, really important. I'm going to give you guys a tip. Go over limits of accuracy calculations, because usually it goes for 2 values. However, 3 values is a unique case. So you're just going to know how you can do that for 3 values, which I just show you right now. Now we have another part of this question, which was briefly explain why resistor RB. Now, if you guys noticed in the whole experiment, we had a hidden resistor over here. If you go back up, we can see this resistor. So we can see this resistor over here. Now, what is the significance of RP? Now, if you guys remember Ohm's law, V is equal to IR, we know that current and resistance are inversely proportional. So we essentially need to add the resistance so it limits the current. maybe there's like a certain reading of current that we should not be exceeding. So that is why we're going to be adding this resistance RP. A continuation of this, I couldn't really find the lines, but like I can explain this to you guys verbally. One possible problem with this experiment is heating. What can we do to reduce this? This is really simple. And we also learn in transformers like a similar concept. Basically, the main thing that we can do is reducing voltage. And that is because if you reduce voltage, that reduces the power output. And if the power output is reduced, what does that mean? Less energy is expended. And if less energy is expended, that means that less energy is lost thermally. So the best solution is to reduce power output by decreasing voltage. The second thing that you could do is increase the resistance. So in particular, you could increase resistance of RP, because we talked about how resistance and current are inversely proportional. Another like logical thing that you could do is switching off the circuit every now and then, so that like you could allow it to cool down a bit before we start doing this again. So these are like some possible ways that we could prevent overheating. Okay, let's step aside from the stupid questions, question 1s and 2s. Let's move on to experimental questions. A student is investigating the relationship between thickness and focal length. So we can already identify two things: independent variable, and we have the dependent variable. So here we have cross sections of a converging lens. The focal length f of a lens can be calculated using the formula. Not really important right now. We just need to plan an investigation to determine the relationship between our variables over here. And we're also given the following apparatus. Obviously, we need an object, we need a selection of lenses, screen, meter rule. I'm going to show you guys how we can do this, okay? In your plan, draw a diagram to show the arrangement of the apparatus, labeling U and V. We got to show out how we can do it. So basically the methodology, and we need to explain how we can determine the thickness and a table. Now, before we get to answering the question, I just wanted to give you guys a general guideline. A physics ATP experiments is entirely different from bio and chemistry ATP. Over here, you have to take a different approach. The bullet points is the only things you need to cover. So if you start talking about how you can like wear glasses so that light doesn't go to your eyes and you become blind because this is like a safety feature, then that's obviously going to be wrong, because we're not, number one, that's not possible. Well, now we'd all be blind. And second of all, there is no bullet point for safety. So the main point is, please just stick to these bullet points, man. Don't do anything else. It's that simple. However, the difficult part is getting to the answer, and that is conceptualizing what you're going to do. Over here, we have the apparatus set up, and we can clearly see the procedure. Number one, don't draw the apparatus in 3D unless instructed to do so, because in 2D it's very simple. Also, it stands out more. It's easier to label. Always follow what the instructions say. The instructions mention how we have to draw it and also include U and V. Now, this isn't like a apparatus that I'm labeling. This is just like the distance I'm labeling. Other than that, mention everything that can, again, help you with this experiment. Second part was also to describe how we can determine the thickness. Now, to determine thickness, we have a separate method for that. And again, remember this staple method for determining thickness is we have the blocks as mentioned in the apparatus given. We place them between the two convex lens ends, and we just measure this distance over here. Just be careful with the diagrams. Always know, okay, if we are dealing with the focal points, then we obviously have to involve screens. You're going to first set up the apparatus. This is something that you always mention unless you're not given the apparatus. Set up apparatus as shown above. So the diagram will typically be located over here. And in a darkened room, why? Because we talked about this earlier. Select the first lens, measure thickness, and record data on a table. Now this is important because we have to draw a table as well. This always comes up. Place the lens in the holder at a fixed distance from the object and label this as U. Now, whenever you're given distances like U and V, or like some variables that you're given just by the alphabet, mention them like that. Slowly move the screen back and forth along the meter rule until a clear image is formed. This is just a recall of theoretical knowledge, where focal point is the point where image is the clearest. It's where the lens, it's where the rays converge the most. Measure the distance between screen and label it V, and repeat for lens of different thickness. Very important to include this in the end, because again, we're investigating different independent variables. Now, how do we measure the thickness? We stand a lens on a flat bench and place the two wooden boxes vertically, not horizontally, because again, we got to make sure that everything is perfect over here. We're going to press them gently. Now, obviously, if you press them hard enough, it's going to break. Use a meter rule to measure the gap between the inner edges of two blocks. This is essentially it. You draw the table as well. Now, the trick with table is you just got to be aware of the headings. That is essentially it. With the headings, you always mention the heading, which is usually given in the question itself, by locating the independent variable and the dependent variable. Now, independent is always on the left side. Dependent variables are on the right side. So we can see that all of these are dependent variables, and we also mention the units. Don't forget that. Okay, moving on. Here we have an investigation for determining the insulator efficiency. So we want to rank insulators from best to worst. Now, guys, what is an insulator? It's something that does not like heat. Following apparatus is available: 5 discs of the different insulating materials. Really important. We're going to be using these. These are essentially our independent variables. So right from the start, you identify the IVs and the DVs so that we can essentially reach the table and plot it, tabulate it easier. So we're going to be plotting the electrical heater with power. This is going to heat this up. The insulating disc is going to heat up a bit. And this is going to be the metal cylinder that we're going to be measuring using the thermometer. So the main principle behind this is the greater the temperature change, that means the weaker the insulator, because insulator is supposed to stop that shit. Now, again, the bullet points, please just follow the bullet points. Explain briefly how you would carry out the investigation. Now, very important, these two should give you, like, if you get all the points like nailed down, you should get 6 marks for this, 3 each. For the table, you'd get 1 mark, and for the conclusion, you'd also get 1 mark. So let's go over this. Actually, you'd get 1 to 2. Again, set up apparatus as shown. Okay, so keep that in mind. Record the initial temperature of the lower metal cylinder, because that is the one we are investigating using a thermometer. Whenever we investigate something, always include the apparatus that we're using. Switch on the heater and start stopwatch immediately after a fixed amount of time. Not even suggested, like I personally like giving and mentioning that, you should have 5 minutes. So examiner knows that you're actually like, you're the real deal. So record the final temperature, and then we're gonna switch off the heater, because again, after we're done with the experiment, it's obviously gonna have some temperature, so we cannot just start immediately. We would allow it to cool down to room temperature, and repeat steps for each of the other 4 insulating discs. Pretty simple, pretty straightforward. Here are some things that we can control: initial temperature, time interval, thickness, room temperature, and power, because we talked about how power relates to thermal energy supply. Now, the conclusion is very important. And usually in conclusion, we talk about analyses in the end, and we talk about plotting graph. Always important. You have to mention that we tabulate and plot a graph for comparison. This is the point you always mention for conclusion. And the second point is going to be based off your experiment as a whole. Better insulator allows least amount of thermal energy transfer, resulting in the smallest temperature change. And then you can mention and vice versa. And vice versa would mean the opposite. Hopefully this is clear. Here's going to be the graph for this as well. Again, disk was the independent variable and the temperatures were the dependent variable. And with that, let's conclude the video. If you have any questions, you can let me know, or you could let this guy know. I don't know, he was just sitting on my desk. I actually wanted to say one more thing. I'm like extremely grateful. Like the support on this channel has been amazing. And hopefully I continue to make videos, because I'm actually doing medicine as well. So life gets a bit tough. But anyways, make sure you guys subscribe. Helps the channel out. Share, completely free. It's up to you. And yeah, good luck with your exams. See you next time around.